Hi, Algebra 2. We are getting ready to start our third unit of Chapter 2. Um, Unlike the first unit where I gave you the equation of a line, either in slope-intercept form or standard form, and asked you to find the slope, the y-intercept, the x-intercept, asked you to graph it. And that's what we did last week, right? Like I gave you something like this, y equals 2x minus 3, and said, what's the slope? And since you knew it was in slope-intercept form, you would say, oh, the slope is 2. What's the y-intercept? And since you knew this was the y-intercept, you would say the y-intercept was -3, or maybe you would write it as 0, -3. Of course, to find the x-intercept, you would put 0 in for y. This is what we did last week. We'd add 3, divide by 2, and we'd say the x-intercept was what, 1.5. Okay, 3 divided by 2, 1.5 comma 0. And you can graph the line by going to the y-intercept of -3, going to the x-intercept of 1.5. Oops, sorry, I'm not very good at drawing lines on here. And then graphing the line, okay? Or if I gave it to you in standard form, you could find the x and y intercepts by putting 0 in for x. If you did that, you have negative y equals 3, so that means y is -3. And then turn around and put 0 in for y. So you'd have 2x equals 3, which, is right here. You divide and you get 1.5, 0. You get the same line. Now to find the slope, you have to play a little bit. Once you find the x and y intercept, you can just subtract the y's, -3 minus 0, right here. Subtract the x's, 0 minus 1.5. You get -3 over -1.5. And if you divide that, you get +2. Okay, or some of you put this in slope-intercept form by adding y over here, subtracting 3 to the other side, and then you can see the slope is 2. Basically, these are the same line. They're just given in two different forms. Well, in this unit, we're going to go backwards and reverse this. I'm not going to give you the equation. I'm going to tell you what the slope is and tell you what the y-intercept is or tell you what the x-intercept is. And you are then going to have to come up with the equation, either in slope-intercept form or standard form. Now, this other form that you're probably noticing, the point-slope form, is used to help us get into one of these two forms. Okay, it's usually used when you know the slope and you know some random point on the line. Then you take y minus the y coordinate of the point you know, set that equal to the slope times x minus the x coordinate of the point you know. And then you can distribute the slope, etc. We'll show you how to do that. I just wanted to introduce it by explaining what was going on here. Okay. Everybody all right? So we're going in the reverse order. For example, in this case, I'm telling you the slope is -4 and the y-intercept is -2. I doubt that I'll say b equals -2. I'll probably say y-intercept equals -2. Okay, and then hopefully you'll realize that that means I told you b. This is the best. When you know the slope and the y-intercept, you just put what the slope is and replace m with that. And you just put what b is and what the y-intercept is, and replace that with b. Now, I don't like plus a negative, okay? It's always nicer to write something with one symbol instead of two, right? So I would write this as y equals -4x minus 2, not plus -2, okay? There we go. We wrote the equation. You tell me the slope and the y-intercept, I'll write the equation. Now, if they unfortunately want it in standard form, that's a little different, isn't it? Okay, so what I'm going to have to do here is rearrange this. All right, I gave it to you in slope-intercept form. And now they want it in standard form. In other words, they want some number x plus some number y equals some number. Notice A, B, and C can't have decimals or fractions, and A has to be positive. Well, luckily, when I add 4x over here, I get 4x plus 1y equals -2. And I'm done. Because A was positive, there's no decimals or fractions. Okay, A is the only one that has to be positive. We like to start our equation with a positive number. So if it would be negative, it would be fine. I would just divide everything by -1, and then that would make the x positive. Okay? All right, so if you know the slope and the y-intercept, you just write the equation by replacing. If they want it in standard form, you move the x term to the other side by, in this case, since it was negative, we added 4x to the other side. If it would have been positive, I would have subtracted 4x to the other side. Here they're giving me the line, but they're not telling me the slope and y-intercept. However, by giving me the line, they kind of are telling me the slope and y-intercept, right? I can see the y-intercept right here. It's 1. Where am I crossing the y-axis? At 1. Slope, I'm not really sure, but I see 2 points, so I'm going to count down 1, 2, 3 to the right 2. Down 3 to the right 2. My friend might have gone the other way. Maybe he started here, then he went up 1, 2, 3, and to the left 2. Maybe he went +3, -2. Either way, the slope is -3/2. So I have my slope, and I have my y-intercept of 1. So when they show me a line, I can write you the equation. And again, to get it in standard form, I'm simply going to move my -3/2 x. I'm going to add it to the other side so that I have my x term and my y term over here on the left equal to a number. Whoops, I have a fraction. Not allowed to have fractions in standard form. So what I need to do is multiply everything by 2. Okay? 2 times 3/2 x is 3x. 2 times y is 2y. 2 times 1 is 2. This is my answer in standard form. This is my answer in slope-intercept form. Same line, just different forms. Okay? All right, let's head to example 2. This time we're given the slope and a point, not necessarily the y-intercept. Okay? So in this case, we know the slope is 2, and we know it goes through a point 2, 1. Sometimes I just kind of draw a quick sketch of what I have. If it goes through the point 2, 1, and it has a slope of 2, okay, that means I go up 2 over 1. I have something like this. All right, so I know this point, but I don't know exactly where it's crossing the y-intercept. It looks like maybe in the negative area, but I'm not sure. That was just a quick sketch. Okay, this is where we use this point or this other equation I was showing you on the front page. Okay, I'm going to write y minus the y coordinate of the point they told me. So this is the point, this is the xy point they told me. This is my x1, y1. Okay, so I'm going to take y minus the y coordinate of the point, which is 1, equals slope, which they told me was 2, times x minus the x coordinate of the point, which was 2. Okay, does that make sense? We use this, it's called the point slope form. Now, I would like to have, it says simplify then and get it into slope-intercept form. So to get it into slope-intercept form, I'm going to distribute my 2 through. 2 times x is 2x, 2 times 2 is 4, and then I'm going to add 1 to the other side. So I get y equals 2x minus 3. Okay, -1 plus, or -4 plus 1. Does that make sense? I wasn't, I probably didn't, I graphed this real quickly. It actually goes through at -3. That didn't look like more like -1, but I wasn't, I didn't do too well of graphing that. But I just wanted you to see that the biggest mistake, guys, that people make with this is what I'll get. I'll get y equals 2x plus 1, because they'll take the 1 here and think that's the y-intercept. That's just a y that goes with 2. The y-intercept has an x-coordinate at 1 that goes with it. Okay, so 1 is not the y-intercept. It's just a point. It goes with 2, okay, as an x-coordinate. So be careful. You have to use point-slope form to help you. Same here. I don't know the y-intercept. It looks like it might be 2.5-ish, but I don't know. I do know a couple points. I know 2 points on the line. So I can find the slope. Remember that slope is you subtract the y-coordinates on top, subtract the x-coordinates on the bottom. So I'm going to take 1 minus -2 on top. Okay, taking these two. And then 1 minus 3 on the bottom. That gives me 3 over -2. I understand too. Yeah, some of you might have just counted 1, 2, 3 over 2, down 3 over 2. Boy, they like the slope of -3/2 in these examples, huh? That was the same slope on the other side. So the slope is -3 over 2. My xy point, hey, I don't care which one you pick. I think I'm going to pick 1, 1. Because then I can't mess up as to which is which. They're both the same. I'm going to take y minus the y-coordinate equals slope times x minus the x-coordinate. I will distribute through -3/2 x plus 3/2. Okay, be careful. I'm taking -3/2 times x. -3/2 times -1 is +3/2. Now, they want this in standard form. So I'm going to add the 3/2 over here, 3/2 x, and I'm going to add the 1 onto the other side. Okay, add 1 here. This is 1.5 plus 1, so that's 2.5. I'll write that as 5/2. Okay, I added my 3/2 x over here with the y, and I added 1 over here with this 3/2. 3/2 plus, you can think of 1 as 2/2. 3/2 plus 2/2 is 5/2. Now I do have to remember the little rule about standard form, no fractions. So you multiply by the denominator to clear the fractions. 2 times 3 over 2 is just 3. 2 times y is 2y. 2 times 5/2 is 5. Okay, so in standard form, this is the standard form of this given line. Now, what if you would have picked what was the other point? 3 -2. If you would have picked 3 -2, then here I would have had y minus -2 equals -3/2 times x minus 3. Okay, x minus the x-coordinate. You still would have distributed through. Here I'd have y plus 2 equals -3/2 x plus 9/2. Okay, -3/2 times -3 is 9/2. You still would have added 3/2 over here. You would have subtracted 2. Subtracting 2 is like subtracting 4/2. 9/2 minus 4/2. Oh, gee, that's 5/2. You would have, and then you would have multiplied by 2 and gotten the same thing. Just wanted to emphasize, it doesn't matter which one of these points you pick, you'll end up with the same line. Okay, the math will end up the same way. All right, tune in for the next 2 examples on the next video, okay?